Okay, so what's one observation that you guys can make by looking at the slope field here? Slope is what? Undefined at x equals -3, right? So that's a really obvious one that we can identify. So that means if I insert -3 into each of the differential equations or into the correct one, I should always be getting undefined. So is there one that I can eliminate? Because we see that's not the case with our options here. First one, right? If I plug -3 in here, am I getting undefined? I'm not, because there's no 0 in the denominator. There's no denominator to begin with. This one can't be it. Is there another one? Third one, right? If I plug -3 in for x, I mean, it's y in the denominator, not x in the denominator. So that doesn't quite fit with that third one. So that's good. We're only down to 2 options here, second or fourth, right? Okay. Is there another easy one that you see? Say it again. Slope 0 at y equals 3, right? See all this right here. Now, anything above and below is not quite slope 0, right? So you see a little bit of slope, but this is exactly 0. So that's a good one to identify. Okay, were we able to narrow down though? Or we're still down to that second and fourth one, right? Still not able to eliminate our choices. Okay. What about positive and negative slopes? Do you see any easy observations there? Okay. Where do you see negative slope? Y is less than, right? Anything that's below 3, I'm seeing all negative slope. Anything above 3, I'm seeing all positive slope, right? So when y is less than 3, dy dx equals less than 0. Right, so if I plug in 4, I should be getting a positive number, right? So if I plug 4 in, yep, that's giving me a positive number. If I plug 4 in here, getting a positive number here. So what if I plug in, let's say 0, right? Because 0 is less than 3, that should be giving me a negative number. So 0. Oh, here it's giving me, still giving me a positive, right? This actually won't give me any negatives at all because y is squared, x is squared. So this can't be it, right? But I definitely see a change and a difference of positive and negative slopes. Okay, try number 6. Okay, any guesses as to what number 6 is? Anybody get x over y? So it follows that pattern that quadrant 1, quadrant 3 is positive, quadrant 2, quadrant 4 is negative. We can cancel some things out. The fact that also I like to look at the diagonals here. It looks like my diagonals are all giving me the same slope, right? 1, 1, 2, 2, 3, 3, 4, 4. It's all giving me the same slope. I know it can't be x squared y because then my slope is going to have to change along those diagonals. But here, x over y allows that 1, 1, 2, 2, 3, 3, 4, 4. No matter how high the numbers get, it's always canceled out with the one below it. Same thing with the other set of diagonals here. Okay, let's finish off with 7 and 8. Page 14. It should be an easy one here for number 7. What you guys get for 7? Yeah, negative x over y plus 1 squared, right? You see that when y is negative 1, slope is undefined, so okay, try number 8. Number 8. Okay, let's look at page 11. No need to worry about finding domain. That won't be on the test. Okay, so we'll find a particular solution, find the equation of tangent line. So I'll just work through this problem at the same time that you guys do it and see if you have any questions. The key's on next page, so if you're working ahead, you can always check your work. Okay. Any question with part A? Shows the negative square root because the y value of my order pair is negative. Okay, so equation of tangent line, I need two pieces of information. What do I need? Order pair and slope. So order pair, I'm only given the x value. How do you think I can find the y value? Into the particular solution, right? And then the slope is going to come from the derivative. Okay. So my order pair is -√6, -1, because if I insert -√6 into the x here, I get -√6 squared, which is just 6. 6 minus 5 is 1. Square root of 1 is 1. The negative carries over, so -1. So I can take my order pair now, insert into my differential equation to get my slope. So I have my order pair, I have my slope. Point slope form comes next. So this is my tangent line equation. And then linear approximation is where I just insert that decimal into the tangent line equation. Right, use it, part D, linear approximation, use it to approximate y of -2.5. All right, any questions? And now I do want to go back to the original graph here. We're not going to ask to find the domain, but I've got to include the directions here to sketch the solution through the given point. Okay, so sketch the solution through the given point. So the point is here, which is -3, -2. Okay, we're just going to follow the path of the graph and follow the stream of this graph here. But as we go down, we can see that it's kind of leading us off the graph, off the grid. But as we go up, what's happening at y = 0? The differential equation is kind of giving us a hint here. Slope is what? Undefined. Okay, so slope is undefined. So make a note of that. So everywhere else, the slope is defined. So it's kind of following along that stream because the slope is defined. But as soon as it hits a slope undefined, that's considered a wall. Okay, so you want to just kind of stop where that wall is. Okay, you're not going to go to the other side and continue. Okay, so we just care about the the branch that hits that point, but as soon as it hits the wall, we stop. We don't want to go and continue to the other side. And again, remember how we had our solution being plus or minus square root, right? But we only chose the negative square root because that was the part that included our solution. So same thing here. We don't want to include both the positive and negative square root. We only want to choose negative square root because that's where the point is located. So that matches nicely with what we are claiming as our solution. Okay. Does that make sense? Okay, number 2, same idea, same process. Again, skip the domain statement, but you can do everything else. Okay, try that. And also sketch the solution through the order, through the 1, 1. See that extra? All that I have to do for myself. You don't see anything before the Y's, but 1 in front. No, imagine that it's 1, you don't see anything. I didn't because it's simple enough where I can just see this is the same thing as this, right? So I just jump directly from the yeah. Whenever you're done with this, we'll do the back page, but just the top portion. Okay, just the y equals cd to the kt problem for A and B. And we'll move on to something else. use the solution from part A to help you find the order pair that you need to build your transline equation. The linear approximation just takes the transline equation and just plugs in that decimal into that transline equation. Yeah. If I gave you I'll give you a order condition, order pair, and then you just follow the stream of the graph and go. Okay, next page. Page 12. You'll just do parts A and B. Don't worry about the rest, just A and B. Just A and B. Okay, the rate of temperature decreases for a cup of coffee. Yes, given by dy dt equals ky. So that's in the form of y prime equals ky. We know that's going to end up being y equals c to the kt. So we'll skip the calculus and jump to this general equation. Now let's build our order pair. For two order pairs, we'll help you solve for c and solve for k. And then part B, you can use that specific solution, particular solution, to help you make prediction as to future values. Oh, I showed all the work, but you can start from this point. Because we know that this is gonna lead to this, so if I have y prime equals ky, we did it one time, but we just knew that I was gonna lead to this, so we just. You have to show the work.
But it will always start with that.
Yeah, for this work problem, I'll start with that y prime equals ky.
Hi.
So we have log properties, right? So the log properties that exponent really come down, so that 5k comes down.
I'm sorry. There.
Oh, okay. So I can either divide by 5 or I can multiply by 1/5. It just feels a little bit cleaner to multiply by 1/5. We can do that by 2 or 5 divided by 5. We can write it that way. So if you want to write it like this, you can. Yeah.
History, history. I'm sorry.
Oh.
It's just for who?
6. Yeah, it should be 190. Yeah, sorry, it'll be 190. Which does reduce to be 2/5. Okay, so I made a mistake there, but that the 2/5 is correct after you reduce it.
Just do what it decreased by, so like, if 5 minutes, it decreased by 76, or do you say something?
No, the order pairs are pretty straightforward, right? Initial temperature, it decreases to 176.
Okay,
So we know that at 5 minutes, the temperature is 76 degrees. So that's right, just something like that.
okay,
Order
if
pair.
it said it decreases by within.
Yeah, I won't give that. I won't do that. But yes, if it was 5, then you would have to subtract, but.
Thank you.
Yes, you can, yeah, no, that's. Yeah, that's fine too. Okay, so now once you have your specific solution, then you can use it to find that third piece of order pair, right? 50 degrees, you want to find the time. So plug 50 in for y and then solve for t. Okay, so divide by 190, take the natural log of both sides. Then just make the calculator do all the work for you then. Okay, any questions here? Okay, guys, go to page 22. So let's spend a minute just reviewing reviewing through those rules, and then I'm gonna put on page 26, which is the blank page, a couple of rules down and see if you guys can recall them. So you don't have to worry about the derivative of a to the u or log base a of u derivative. But you know, the original 6 trig derivatives, e to the u, natural log of u, those we need to know. Power rule, we've been using that a lot. Trig integrals, these just come from the original 6 trig derivatives. 1 over u du, e to the u, a to the u. These are ones that we've been using recently from the quiz. And then more recently are the 4 trig integral rules and the arc trig rules, right? And then don't have to worry about the arc trig derivative rules. I'm not going to have those on the test. Okay. So study these ones there. I'm going to put some of these on page 26, and then just have you guys see if you can recall these rules. Okay, so yeah, so study from this down. These are the more recent ones, and I'll just pick a few to put up. Okay. Okay, so e to the u du is, yep, the original, yeah. A to the u du. Log of A. Yeah, very similar, right? The original function shows up. We just need a little bit of conversion in front. Tangent u, this is one of the newer ones involving natural log. Good. You know tangent is sine over cosine. That denominator is going to show up. You see the letter C, that indicates that the negative is going to be part of your rule. Right? Du over a squared plus u squared. Yep. Artan, yep. Most of the arc trig has 1 over a except for what? Arcsine. Yeah, arcsine has no 1 over a in front, but arctangent and arcsecant does. Okay, secant u, also one of our newer ones involving natural log. Natural log, absolute value. Yeah. Number 6. Arcsine. Yeah, the constant comes first. Cotangent u. This is cosine over sine, right? So natural log. You see, there's no s, there's no c in my rule, so no positive. Finally, 1 over u du. Natural log. Yeah. All right, so study for your test tonight. I encourage you guys to go through worksheet 4 on your own, just to see where you stand. But tomorrow morning, I'll be going over worksheet 4 for your test. All right, can you go get your phones? I did it today, this morning. Okay. And then, yeah, so yeah, tomorrow morning.
That's like 3 pages. And you know, video of art stuff, like, hold up.
On the day of the notes I did.
Okay, so I could go back to one, because I have no clue. Like, I kind of figured it out, but it's like,
You have a less period.
I have to take a serious moment already. But I'll just go home and watch it.
And I usually, I set it down to a while, so if you were to take the square root, then what would that do? One of these light things, X and C, wouldn't it?
No, it wouldn't. It would be y equals plus or minus square root of x squared plus. So that's why I like to solve for c first before the square root comes in. It just makes it messy.
So you really go all the way up to the line before you get to it.
So typically my rule of thumb is what's the easiest equation for me to plug in my order here? That's for me.
For a second, how did like, when you plug the square root or negative square root of space in, how does it go to that?
It's not x. It's it could be this. So that's
Just for him that I forgot to show you.
yeah, so it probably doesn't like it if
It is.
the order of operations is kind of messed up. So either use the n over d feature or you put big parentheses around that entire thing. 1/5 is 1/5. It's divided by 1/5 and then it's multiplied by natural figures. That's that.
Yeah, got it.
It's that one.
How do you know when to use those, these zeros over like what we have?
I email my teacher.
So typically the way I tell is look at the degree of the denominator. If there's something.
My teacher. I don't do that because I just.
So there's that, yeah.
Okay, so
That's indication that it's gonna be a hard trick. But if it's like, yeah, we're just.
Go back to.
Right, this is gonna be, you want to set the entire good out of it. We might get that gap of student. So we saw that with, the arctangent problem.
Yeah, she does. Mine is just, I just goes with this. It's actually what I don't wanna do.
You saw from my says, right? Degree 2, degree 0, there's a cap of 2, denominator's higher. That gap is indicated.
Two or more.
2 or more, 2 or more.
I guess sure.
All right, guys, study for your test. See you tomorrow.
Thank you.
Thank you. Have a good day. Thank you.
Later.
Yeah.